Hello, I'm here today to talk to you about chemical engineering. And first, I'd like to do the territorial acknowledgement. The University of Waterloo acknowledges that much of our work take place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, the land granted to the Six Nations that includes 6 miles on each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within the Office of Indigenous Relations. And as for me, my name is Kaylin. I'm going into my 2B year as a chemical engineering student, so I'll be graduating in the fall of 2028. As a student at the University of Waterloo, I've been involved in the academic class representative. I'm one of the 5 reps that foster communications between professors and students. So if there's too many midterms scheduled in 1 week or too many assignments due on the same day, that's our job to communicate that to the professors. I'm a frequent ceramics club workshop attendee. You can see on the picture on the side, I'm holding up a little frog bowl that I made. It's really nice decor to add to your home. And in my first year, I was a part of a student design team called the Concrete Canoe. And I think that contributed to me landing my co-op at St. Mary Cement. So it's always great to get involved. As for my most memorable student memories, the solar eclipse. I didn't have any solar glasses. They ran out across all the stores. So Bert, you can see in the background a little bit, handed me his welding mask so I could look at the sun through it. Purpling is when everybody woke up at 6 a.m. or something crazy like that to dye ourselves purple. It's quite the experience. And very recently in our CHE 200 class, there was apparently an alien, and our prof was sending out emails after emails about an alien invasion. Yeah. And as for top tip for engineering student life, just remember that university is what you make it. So keep searching for new experiences. Sacrificing connections for the perfect grade is not worth it because it doesn't exist. What I love about Waterloo and chemical engineering is first, it's hands-on learning experience through co-op. You can see from the pictures, the one on the top, I'm dressed professional in an office, clean. But the second picture at the bottom, dusty, right? Industrial at a cement plant. 2 very different experiences that I really value. I think it taught me the different branches you can do as a chemical engineer, and you only get that through co-op. And secondly, the cohort or class size, you really connect with everybody in your class, and you can ask teachers questions that I know my friends from maybe other university don't really get to do because they have a huge class and there's no way for you to like shout from the very back. And they're the people I met, very wonderful people in my 2 years at the university, and I've made some pretty good friends, I'd say. So we'll get into the differences between chemistry and chemical engineer. Chemical engineer Chemical engineering needs chemistry, right? It's about the rearrangement of atoms to make something from raw materials to create a chemical transformation or biochemical transformation. Sometimes we're talking about reactions that happen in biological systems. It's the rearrangement of atoms to make things. Chemists do that. But what's the difference? So the difference is that chemists will make the reaction happen to produce something and to discover how the rearrangement went. They'll do that on a small scale, in a beaker. They'll stir things and analyze the result and will discover how this thing happened. But if you want to make these things in large quantities, chemists would be at a loss because it's easy to store a beaker, but what if you want 100 tons of material a day? How would you scale that up? So in a beaker, if it's too hot, you can just dunk in the ice and you've done it. But if you have a evaporator the diameter of a building, what are the safety considerations? If you spill the beaker, nothing can happen, but with the building-sized evaporator, people might die, right? So you can get in a lot of trouble. And that is chemical engineering, is trying to do things safely and economically. We make chemical transformations, but in large scale so that it can impact society. Which of these do you think chemical engineers make? So we have poker chips, computer chips, and potato chips. Well, the answer is all three. Almost everything we touch and use every day has involved chemical engineering at some stage. Chemical engineers have a hand in producing many of the products that people rely on. Chemical engineers produce biofuels, plastics, and polymers, renewable energy, pharmaceuticals products, and much, much more. We work in the food processing industry, the cosmetic and beauty industry, and automotive sector, and more. Why are chemical engineers known as the universal engineers? At times, people have referred to chemical engineers as the universal engineers because of our scientific and technical expertise. Chemical engineers are often referred to as the universal engineer because of the wide range of skills and knowledge we possess, which enable us to work in various industries and fields. We're trained to solve complex problems, optimize processes, and improve efficiency in a variety of settings. We use our knowledge of chemistry, thermodynamics, fluid mechanics, and other sciences to design and optimize processes that are safe, efficient, and environmentally friendly. The broad skill set and problem-solving skills in a degree of chemical engineering provides makes chemical engineers in demand in a variety of roles. Today, chemical engineers are finding new sustainable ways to re-engineer the products society relies on, contributing to creation of a circular economy, which aims to reduce waste and sustainability by keeping resources and materials in use. In a circular economy, materials are reused, repurposed, and recycled rather than just being discarded. An excellent example within our department is Professor Kostas Tsouganakis. His company Tyromer recycles car tire rubber. He developed a new chemical-free technology to break down old tires and create a value-added rubber compound used in the production of new tires. So circular economy. And chemical engineers are uniquely positioned to advance all 17 UN Sustainability Development Goals. For instance, number 13, climate action. Chemical engineers are active in several different aspects. We're engaged in carbon capture and utilization. So they create sustainable energy sources and help with energy storage and grid management. Chemical engineers are involved in environmental remediation and are creating sustainable bioenergy. Chemical engineers have a critical role to play in the entire food system, from developing eco-friendly fertilizers to biodegradable packaging. The global food supply system, from agriculture to transportation, accounts for almost a quarter of greenhouse gas emissions, and chemical engineers work to enhance the whole process to be more energy efficient. Chemical engineers can also be experts in wastewater treatment, desalination, and help to provide clean water. And these are just a few ways that chemical engineers are engaged in climate action. So you could imagine all the contributions made to all 17 goals. And a little bit about chemical engineering at University of Waterloo. The Department of Chemical Engineering has 9 research chairs. That means they are the top experts in their field in Canada. Here we highlight 3 of our Canada research chairs. Professor Valerie Ward has expertise in biomanufacturing, which is using biological processes to manufacture products like antibiotics or protein for pharmaceuticals applications. And Dr. Evelyn Yim focuses on technologies that can repair, regenerate, or replace damaged cells and tissues. So that's more of the biology side. And Tazazu Mekkonen environment. Tazazu Mekanen specializes in the production of sustainable polymers and plastics that have environmental benefits. So he uses polymers for everything from coating seeds to agriculture to making bulletproof vests. And if you're surprised, some of the things that chemical engineering encompasses, you should check out the research page on the website to find out all about the other exciting areas that chemical engineering can be applied to, such as capturing CO2 and converting it to renewable energy. The key differentiators from chemical engineering at the University of Waterloo and other universities are that it's one of the largest department in Canada, but the class sizes are quite small, so you actually get to connect with your professors and students, and it offers diverse learning opportunities, has state-of-the-art labs for experimental learning, such as the Ontario's only pilot-scale distillation column. You have access to participate in research and contribute to research publications. You also have opportunities to collaborate with peers who are the top STEM students from across Canada and the world. And there's many entrepreneurial opportunities as well. So in first year classroom, chemical engineering students learn foundational concepts in process analysis, mass and energy balances, chemistry, biology, physics, and engineering math, which is calculus and linear algebra. We also develop skills in programming, communication, and design through hands-on studio courses. So one of the highlights in your first year are the first year design studio courses. These courses focus on hands-on learning and skill development. Students engage in problem solving, engineering design, data analysis, and process investigation while emphasizing safety and effective communication. These courses provide practical experience to complement theoretical knowledge that you would learn in like physics and calculus, and it prepares us for real-world engineering challenges. Also, in first year, we begin building knowledge in the 5 areas of chemical engineering. So one of that is thermal dynamics, understanding how energy works, moves, transforms, and here's why it's such an exciting part of chemical engineering. When you work with energy, it teaches you how to use energy efficiently, about how to convert heat into power, cooling system, or figuring out how much energy a reaction needs or produce. You also learn to optimize, so why some reactions release a lot of energy and others barely budge, and how to control these processes to make things like fuel, materials, or medicines. You also learn to build a sustainable future. So thermodynamics is key to creating a greener, more energy efficient solutions for industries, and it helps reduce waste and combat climate change. It's a subject that connects science to real world applications, and it helps you understand and improve the systems and that power everything around us. And this slide outlines the study and co-op work sequence for chemical engineering students. There are 2 possible sequences, both of which alternate between academic term and co-op work terms. This program follows a 5-year format with 6 co-op terms integrated into the academic schedule. So students will switch between the study terms, that's 1A, 1B, 2A, etc., and the co-op terms, which are marked like co-op 1, 2, 3. And what this does is it allows students to apply what they learn in the real world setting while learning valuable industry experience. This structure is what makes Waterloo's chemical engineering program unique. It provides a balance between academic learning and practical industry experience. So whether you're in Stream 4 or Stream 8, both pathways lead to a strong foundation for strong careers in chemical engineering. And here are some of the branches that you can go into as a chemical engineer. You can do environmental, advanced materials, there's fuel and energy, automotive, basically anything that you can put your mind to. And here you can see the sectors that our graduates work in. You'll notice some of our alumni work in software and IT, and as much as this may surprise you, there's a branch of chemical engineers that exclusively work on computers, doing simulations, machine learning, AI, and computational multiphysics. So if you're interested in working with computers to solve real-world engineering problems, you can find a place in chemical engineering to do that as well. You can see that a lot of graduates work in the process manufacturing sector. Chemical engineers are masters of skill up, and that's one of the reasons chemical engineers are employed in every sector of manufacturing. Whether you're scaling up a huge vat of makeup foundation, or soft drinks, chemical engineers are part of that manufacturing process. So very diverse. And if you have any questions,